Good morning, dear students. Good morning, all of you. So, this is a video of class 11, and in this video, we are going to talk about the resonance. It is the displacement or shifting or movement of pi electron. Okay, now? So, you know that pi electrons actually exist in the double or triple bond. So, resonance will also exist in the unsaturated compound where the multiple bond would be there. Again, so pi electron or lone pair would be there. Then you can see their displacement would be there. Displacement, shifting, or movement, we can write any of the thing. Okay, so that the resonance will take place on the whole. You can say that if this would be the conjugation pi or double bond, sigma single bond, and if you are seeing lone pair, okay now, if you are seeing lone pair or negative charge, then their resonance will exist. Okay now, the next point, it is intramolecular. What is the meaning of intramolecular? The resonance, the shifting of pi electron actually takes place inside in the compounds, so that's why it is intramolecular. Okay na? It is intramolecular. The resonance are hypothetical. What does it mean? Means if I am talking about one of the structure of benzene, here I can show you what does it means hypothetical. Here I have made one structure of benzene, and here you can see double bond is at this position, double bond is at this position, double bond is at this position. Individually this benzene will not tell its all the characteristic properties, because this we know that resonance structure of benzene we can write in this form also, because double bond will move and from this position it will come at this position, at this position, and this position. So that one is hypothetical, not real. Okay na? The resonance structure of any of that any of the compounds will not individually tell you all the characteristic properties of the structure of the compound. Okay, so let's see. Okay, so here we will discuss about the resonance in detail, and you can see the resonance is actually the shifting movement and displacement of pi electron. Pi electron lone pair also can displace. Okay now, so this is the thing you should know. But where, in which type of compound the resonance will take place? If you are seeing pi, sigma, and lone pair, conjugation would be there. What is the conjugation? Means in the serially pi, sigma, and lone pair would be available, then only the resonance will take place. Okay now, so you can see that here we will discuss the resonance in detail. About, I will take some example also. Okay now, so here we can see some of the structure. Here first of all I have made benzene, and in the benzene you can see this is at this position. Resonance, when you are writing, you have to give this arrow both side. This one is the sign that resonance is actually taking place. Then we will shift this pi electron from here to here, this will automatically shift here, this will automatically shift here. So it will actually give you this structure. Okay now, but this is alone. If I have to write the complete structure of this resonance, then I will make one hybrid structure of this one. And what is hybrid? Hybrid means, hybrid is combination of all resonating structure. Okay now, in this one you have understood that in the benzene only two structure, 1 and 2 is there, its hybrid is this one. This alone, one number in the benzene will not give its all the property of benzene. Second, also will not tell you all the characteristic properties of benzene. But this hybrid compound of benzene will tell all the properties of benzene. Here I have taken this circle form, that means this is the distribution of the double bond in this benzene. Okay now, so this hybrid structure will tell you everything. Okay now, one more structure I will show you, that one is carbonate ion, CO3 2 negative. Okay now, how can you actually write its resonating structure? Here you know that carbon, and here at the top oxygen would be there, 2 negative, here one oxygen is here and one oxygen is here. Okay now, here negative charge, 2 negatives there, negative here I have taken, and here also I have taken one negative, 2 negative. But this oxygen have deficiency of the electron, lone pair electron. So what you have to do, you have to write the lone pair here. Okay now, lone pair here you will write. Okay, lone pair here you will write. This double bond, ultimately you have to, what you have to do, you have to see that pi electron sigma and this lone pair would be there, that means resonance will take place. So what will you do, you have to change this double bond here. Then from this oxygen, lone pair will come here. The second structure of the resonance would be what? C. Now this one bond has broken and it has gone here. So what will you write? O. Okay now, only one bond would be there. So O would be there and negative, then 2 electron would be there. Okay now, it has taken the electron from here to here. So gaining of electron, negative charge would be there, and this electron is coming here in between carbon and oxygen, so it will carry double bond O. Okay now, and then this one is single bond O negative. One structure you have understood. The possibility is the other also, or other possibility is also there. This electron you have changed, shifted here to here, this also can shift na, this bond can move to go here, this electron can also. So third possibility is also there, and that one is C double bond O, sorry, C double bond O, no, here this electron will go C O, O negative, then here double bond O, O negative. So this one is the 3 case you can see that actually exist in carbonate, where the pi electron has shifted and it has given some opportunity to other oxygen to place this electron at some of the different place. Here in the first case you have seen these 2 electron went at between the carbon and oxygen and form C double bond O, and in the second case this oxygen form C double bond O. Okay now, so this you have understood. One more example I will give, and that one is of phenol. Okay, so phenol I will write here, phenol, this one is phenol O2, and here also you can write OH. Okay now, So you can see this one is a phenol, and if I have to write its resonance, then I will take this electron, lone pair of electron, and I will fill here. So there double bond will come. Double bond, that means here the carbon is there, and how many what is the bond, total bond, number of bonds for this carbon, 1 2 3. This double bond will increase 3 4 1 5. So there would be the problem. So anyhow I have to manage this double bond at this position. Okay now, so what would be the second structure? This electron will come here. Okay now, so what it will form? CO H lone pair. This lone pair will remain, and here negative charge would be there. Then this double bond would not present here. I will write like this one. Okay now, then after this negative charge will go here. Okay, and from here this double bond will come here. You have to see that only negative charge will move, rotate at ortho, para and meta position. So this one is ortho. Now next time it will come at para, and next time it will go at meta. You have to see also this thing, that wherever you are taking the negative sign, you don't have to give the double bond. So you can see that it has formed double bond O hydrogen. Okay, and negative charge came here, so double bond is between here. Now the second time you have to write here, and the structure will become this one. Second time here, so you cannot write the double bond here, so double bond you can write here O H. Okay, four structure would be there, and in the next time what you have to do, you have to write this structure only. So this time it will go here and this here. So this one it would give you the same structure, that one is O H. Okay now, so here you have seen that all the negative charge went, and this first structure and second structure would be the same one. Okay, so this is the thing for the resonance, and all the 5 resonating structures are there. Okay, thank you.